Hello and welcome to section 6.3. In this section we are going to cover separation of variables. That's the main section of this, and so I have two examples for how to do that. And so our first example looks like this, and basically a separation of variables means that we want all the x's on one side of the equal sign and all the y's on the other, and that includes the dx and the dy. So it's going to take a little bit of algebra to move things around, and so I have, since I'm dealing with x squared plus 4 dy dx equals xy, I'm going to move the dx across the equal sign by multiplying, so I end up with x squared plus 4 dy will equal xy dx. And then I need to move the y over to the y side and the x's over to the x side. And so what that gets me then, I'm going to divide by y, which will get me x squared plus 4 dy over y equals x dx. It's starting to look better because I can only have x's on one side now. And then I'm going to divide by x squared plus 4 across the equal sign, and that will get me dy over y equals x over x squared plus 4 dx. So now I've separated the variables, and to find a general solution, that means we don't want the change in y and the change in x, so we need to integrate this, which is what we'll do as our next step. And so then we'll follow it up this way, up here. And so if I integrate this, remember that this is 1 over y, and so I end up with just the ln of y. And it's plus c, but remember we're adding a constant here. If we add a constant on the other side of the equal sign, adding and subtracting a constant together will get us more or less a constant. So we'll just take care of that constant on the other side over here. Now to integrate this is going to take a little bit more work. If I made u equal to x squared plus 4, du will be 2x dx, which means that I could replace the x and the dx with that, but I've got twice as much as I need, so I divide by 2 on both sides. And so I'm left with, now I can replace x dx with a half of du. So I end up with 1/2 of du over u, which is really what I was looking for. So now I get the ln of u, 1/2 the ln of u plus c when I do this, and u, you remember, is x squared plus 4, so I end up with 1/2 the ln of x squared plus 4 plus c. Now this would be nice if this was my general solution, but we are almost there. We just need to get rid of the natural log, because a general solution, if you guys remember, is y equals. And so I'm going to do y equals across here, but in order to get rid of the y equals, I have to get rid of the ln. And so our opposite operation for ln is basically to make it the power of e. And so that's what I will do across the equal sign here. And probably my best bet would have been to put this 1/2 as the power over here to get rid of this. So maybe before just a little simplification, maybe before I do that step, maybe it would have been better for me to write it like this: ln of y equals ln of x squared plus 4 to the 1/2 plus c. Now I do my base e to everything. And in this case, well, the e and the ln cancel out, so I am left with y, which is what I'm looking for. Here, this is e to the ln of this thing, the square root, so I'm looking at the square root of x squared plus 4. And then plus c, well, now these guys are powers, so of the same base, so we're really multiplying them together. And when we multiply them together, we need to make sure we add the exponents, and that's really what's happening here. Now remember also that e to c is a constant, so e to any power that is a constant means that it's going to also be a constant. So I don't need to write it as e to the c, I'm going to write it as c. And then finally, we have to take into account that we would be solving this, and we probably have to put a plus minus in front to just represent that we are taking the square root to solve this equation, and it wasn't originally in the problem. So we would have to take care of this. And then if you went through and differentiated this, you would find out that the positive version is really the general form that we were looking for. So that is example 1. And then example 2, this time they're giving us an initial condition to find a particular solution. So hopefully that triggers in your mind that you're looking for, now you're going to need to find the c to get the final solution. So we're going to do the same type of thing as we did before. We're going to get the y's on one side and the x's on the other. And then we're going to solve for c, because they gave us x is 0, y is 1, and we'll go from there. So starting out, let's see, I'm going to move this 2x, or xy dx across the equal sign by subtracting. And so I'm really left with y squared minus 1 times e to the negative x squared dy equals negative xy dx. Well, again, I'm stuck with an x on one side and a y on the other. So I'm going to divide both sides by y in this case. And so now I'm left with y squared minus 1 times e to the negative x squared all over y equals negative x dx. Getting a little bit better. If I divide by e to the negative x squared on both sides, then I would do this. And so then these guys would cancel out. So then I'm going to do a little simplification. I'm going to divide everything by y. Oops, I lost my dy along the way here. My dy should be here. And so I'm going to divide everything by y. And so I'm going to end up with y minus 1 over y all times dy. And over here, since I have e to the negative x squared on the bottom, remember a negative exponent means we're on the wrong side of the fraction bar, so I could write this as negative x e to the x squared. Losing the negative because we're pushing it to the right side of the fraction bar, the correct side of the fraction bar. So now we have this problem that we get to deal with, and this is the one that we get to do our integration about. And so that's what I'm going to do. So I would integrate both sides of this to end up helping myself out. And so when I do that, let's see, we'll try to move over here. When we do that, well, this becomes y squared times 1/2 minus the ln of y. That gets rid of the dy. And then on the other side, if I make go down here, if u equals x squared, then du would equal 2x dx. So that means I have more than I need, so I'm going to take 1/2 of dy, or du will equal x dx. So 1/2 du will equal x dx. So that basically means that when I plug this in, I have the problem of 1/2 of, well, this is, I can replace I'm going to pull out the negative, and then I have x dx, which is right here, being replaced. So then that's really 1/2 e to the u du, negative 1/2 e to the u du. So then when I do this, the integration of e to the u is e to the u. So I'm left with, up here, negative 1/2 e to the x squared plus c. So there is my solution for this, more or less. I'm not going to work. I will try to get this into y equals form as close as I can, but this is going to end up being something that would, if we were going to differentiate it later, we're going to have to implicit differentiate it. So I'm not going to get it y equals like a standard line equation. I'm just going to try to get all the x's and y's on the same side of the equal sign and equals c. So I'm not going to work too hard on this, but I'm going to go ahead and figure out what happens when x is 1 and when x is 0 and y is 1. So I'm going to go through and plug that in. I get 1/2 times 1 squared minus ln of 1 equals negative 1/2 e. Now if x is 0, it's really to the 0 power plus c. So I really have 1/2 minus 0 equals negative 1/2, and then e to the 0 is 0, or is 1, so I get just negative 1/2 plus c. And if I combine like terms or move the negative 1/2 across the equal sign, we find out that c is 1. So what I'm going to do is I'm going to rewrite this as 1/2 y squared minus ln of y plus 1/2 e to the x squared equals 1. Now, you might want to multiply everything by 2 just to get rid of the fractions, but I'm sure this would be an okay answer for me. If you multiply everything by 2, that would be another form of the same answer, and it would probably look something like this, as the same answer, just in a slightly different form. So either one of these guys would be okay for our separation of variables and our particular solution. So if you guys have any questions about these, please come to class prepared to ask them, and we'll talk more about this in class.